Okay, we are jumping to the next level now, going from 10 tons to 100 tons. So we are going for bigger and bigger things, not necessarily better because these are carbon footprints. Here we are talking about a car crash. Just a random item, not sure exactly how we would use it, but it's always better to avoid a car crash, I suppose. So it's 0 gram CO2 equivalent if it's just a tiny bump that you can live with and you don't claim insurance. You don't have to get it repaired. It doesn't degrade the performance, mileage, and so on and so forth. Jumps to 7 tons CO2 equivalent if the car becomes a write-off on an empty road. And it's 50 tons CO2 equivalent if it's a double write-off on a busy highway. You know, there is traffic stopping, people having to idle and crawl and emit more, losing their time, insurance involved, paperwork involved, maybe hopefully no hospitalizations and so on. So obviously this has infinite scope in terms of how many things can add up in terms of a carbon footprint from a car crash. So just keep in mind that car crash does have consequences in terms of carbon as well. Just to put some light on it, here is a map of the world statistics of road traffic deaths and the rank of Iran in this list, because this paper is by Iranian authors, and you can see that this MENA region, Middle East, North Africa, is quite bad in terms of traffic death rates. These are per 100,000 people per year. This is the latest data available from this 2019 paper. So these regions have less than 7.2, 7.2 to 11, and so on. And here we are in the range of 38 to 48.4. Per 100,000 people per year. So you can imagine how bad it can get. So even a place like Afghanistan, which hardly has too many vehicles, is very high in this number. So there you go. It's very non-uniformly distributed, but obviously carbon footprint associated with these accidents do add up. In general, the human impact of a car crash in which two $22,500 cars are written off and a 50-year-old dies. There is a 10-mile motorway queue lasting 2 hours. If you have a fatal accident on a highway, it's very likely that traffic is going to back up for hours either way, not just to clear up the accident site, but for the investigation, the ambulance, the fire vehicles, and so on and so forth, fire engines, and so on and so forth. The figures exclude the indirect effect on family and friends. So car crash victims, 30% years lost. Queue victims, 3% years lost. So this is stuck in the traffic that backs up. Climate change victims, 25% years. Obviously, a lot of uncertainties in these calculations, but it's in the book, so I'm including it. I'm not completely sure of the motivation of including this, but a new car makes a bit more sense because you often have to choose whether you want to keep running the old car that is in reasonable shape, not burning too much gasoline, and how much longer it will last, and whether buying a new car really makes sense in terms of lifetime savings on fossil fuels and emissions, and also its longevity, etc. 6 ton CO2 equivalent for a smart car with basic specifications. 17 tons CO2 equivalent for a Ford Taurus, which I'm not even sure is being manufactured anymore. Used to be a popular car, even in Europe. 35 ton CO2 equivalent if it's a Land Rover Discovery, top of the range. So obviously SUVs of this type have higher footprint, but the car company started selling SUVs to so-called soccer moms, saying you can haul your kids around, you can have their friends come along, and you can be safe in your car because SUVs are much safer in traffic than smaller cars, and so on and so forth. So a new gas guzzler could eat up 3.5 years worth of 10-ton living before you even drive it off the lot. That's just how much it takes to make it. It's not as much as this if you trade in your old car for a resale. That's always something that is offered by most dealers. They will offer you some price for your old car. So the carbon footprint of the cars themselves per mile, these are the different models, these are the prices. So as the price range goes up to, let's say, the Land Rover Discovery, the embodied emissions in terms of tons of CO2 equivalent goes up as well. Embodied emissions, I will show some figures. Either basically what emissions are occurring when the product is made, whether it's a building, a car, or anything else, and when you buy it, it already has that much embodied emission in it, and then you have to count how much you're going to emit after you start driving it. Okay, so embodied emissions per mile over 100,000 miles gram CO2 equivalent also increases for bigger cars, and embodied emissions per miles over 200,000 miles begins to decrease, as you can see, for all of them. So the longer you drive a car, the better. So it's always better to keep an old car than to trade it in for a new one, and especially if you're going to buy a bigger one. But of course, if you are switching to an electric one, hybrid one, and so on, then there may be some advantages overall. Okay. The carbon footprint of a car itself, gas and electricity used by vehicle manufacturers themselves account for 12% between them. Each of the other slices could be broken down again into yet another pie with a similar story. For example, the footprint of the plastic product slide comes partly from the gas and electricity used by that industry, and partly from everything else across the economy that plastics industry spends money on. NEC stands for not elsewhere classified. So there are various items here: non-ferrous metals, iron and steel, plastic products, rubber products, plastics and synthetic, direct emissions, other, electricity production and distribution, electrical equipment not elsewhere classified, mechanical power equipment, other metal products, metal forging and pressing, etc. What can you do with this information? Just keep these things in mind: a Citroën C1 versus a Prius hatchback, which is larger here, and remember that Prius is a hybrid, so that's something you have to keep in mind. Ford Contour, Land Rover Discovery. So when you buy, you can do these research and buy an environmentally conscious car. Okay, if you can live without a car, ride a bicycle, ride a train, ride a bus, share a car ride are always better, of course. Okay. Another item that is maybe more sensible in considering is a wind turbine. I'm not sure individuals will have wind turbines in their backyards, but hopefully as materials become lighter and efficiency goes up, maybe like solar cells, many houses with space will have windmills. So 30-ton CO2 equivalent, a 50 kilowatt turbine installed, 500 ton CO2 equivalent in net savings over a 20-year lifetime. So that's what you have to look for. This section contains payback calculations that will interest some more than others. Basically, the idea here is that if a government is subsidizing feedback tariffs, so if you generate power that you don't use and put it on the grid and you get paid for it, then the government is spending a certain amount, you are investing a certain amount and getting some power out of it. So if you compute the amount of carbon savings that the government is subsidizing by paying you for your feed-in tariffs, then it often turns out that government is paying way too much in terms of price per ton of carbon. In other words, the government is better off investing that money in a offshore wind energy farm than to motivate individuals to invest and put a little power back on the grid and reduce the carbon a little bit. So cost and carbon cost have to be considered carefully here. In terms of life cycle, system boundaries, so raw materials are extracted, suppliers bring it to the manufacturers, there is transportation and installation, operation and maintenance, energy to the grid there, waste has to be hauled away, there is some recycling probably happening, and there is landfill and incineration. So as number of windmills go up, wind energy farms go up, just like we talked about the recycling problem for solar cells, this is also beginning to add up, so one has to worry about that. And in terms of the energy footprint, after measuring the environmental effects for all impact categories, the tower and foundation for both onshore and offshore turbines have the highest level of environmental impact. So here's the tower and foundation. So 51% of together, and 49% is coming from the rotor and nacelle. The nacelle is all the gearbox that contains the mechanism that converts the rotation of the windmill into electricity or power or energy, right? So you can see this onshore and offshore. The numbers are different here. Offshore foundation is much cheaper, but the tower is more expensive, and here the percentage of tower plus foundation goes up higher than here. So the nacelle, this is what the nacelle is. Here is the windmill blades going out. There is a main bearing, gearbox, generator, pennant plus wind meter, control cabinet, revolving motor, and so on and so forth. Okay. But over a lifetime, you can compare air pollutants like sulfur dioxide, NOx, PM10 released from wind and coal power plants. So the advantage of renewable energy often depends on what you are comparing against. If a windmill is replacing a coal power plant, obviously the impact is much higher than if you are trying to replace a nuclear or a hydroelectric, for example. Wind power generation results in 80.38%, 57.31%, and 30.91% reductions respectively in these three things. So you can see here PM10, sulfur dioxide, and NOx from wind farm establishment, wind turbine production, wind farm operation and maintenance, recycling and disposal, what a coal-fired plant produces, what a coal-fired plant installation, plant production, installation, and operation. So obviously this is what we are striving for: reducing carbon footprint, improving air quality, human health, and of course overall trying to keep the fossil fuel in the ground, especially coal. Leaving the assets buried in the ground is not easy. This is what the fossil fuel companies are fighting so hard against. All the incentivization for renewables they are arguing is not needed anymore, but obviously depends on how you count these carbon footprints, but all the related externalities like quality of life, air quality, quality of the energy, overall water quality, and so on and so forth. Okay, we will leave it here.